Hello guys, welcome back to the Universe of Checkup. In this tutorial, we will learn about bubble sort. We are diving into the word of sorting algorithm, specifically focusing on bubble sort. So, what exactly is bubble sort? Bubble sort is a simple and intuitive sorting algorithm that organizes a list of elements in a specific order, typically in ascending order. It does this by repeatedly stepping through the list, comparing adjacent elements and swapping them. If they are in the wrong order, the process continues until the entire list is sorted. The bubble sort is a simple sorting algorithm. They comparing the adjacent elements and swapping them if they are in the wrong order. The process is repeated until the list is sorted. The name bubble sort comes from the way smaller elements bubble to top of the list or the beginning in case of ascending order. This is a in case of ascending order as a larger element sinks to the bottom. Taken on example, imagine you have a row of books and you want to arrange them by height. You start at one end, compare the first two books, and if the taller book is in front of the shorter one, you swap them. You keep moving down the line, comparing and swapping until you reach the end. And then you start over ignoring the last book because it's already in the right place. This is the essence of bubble sort. Why is bubble sort used? Now you might be wondering, why do we use bubble sort? While it's not the most efficient sorting algorithm, it has several advantages. Stable sort means it maintains the relative order of equal elements, which can be important in certain applications. In bubble sort requires only a small amount of additional memory space. And next one is simplicity. Bubble sort is easy to understand and implement. Next, we move on to the applications of bubble sort. In bubble sort, we use it in the educational purpose, teaching basic sorting concepts and algorithm design like that, and also use it in the small data sets, small lists or arrays. And next one is used in the embedded system where memory and processing power are constrained. Bubble sort can be appropriate choice. Next, we move on to the algorithm of bubble sort. Here is the step-by-step outline of the bubble sort algorithm. First, start at the beginning of the array. Start with the unsorted list. Compare the next one is repeat the following steps. No swaps are made for each element in the list up to the last unsorted element. It means compare the first two adjacent elements. If the first element is greater than the second, swap them. Move to the next pair of the adjacent elements and repeat the comparison and swap if necessary. Continue this process until you reach the end of the array or list. After the first pass, the largest element will be in its correct position. After the first pass, the largest element will be in its correct position. Repeat the entire process for the remaining elements, ignoring the last sorted elements because continue until no swaps are needed, indicating that the array is sorted. Next step is end, when a full pass is made without any swaps. Bubble sort is a straightforward sorting algorithm that is easy to understand and implement. Let's take one example. Here is the example. The example 1 is 67, 78, 80, 55, 30, 13, 85. This is the initial list. First, we need to compare 67 and 78. The 67 is greater than 78? No. No swap. The list is 67, 78, 67, 78, 80, 55, 13 and 85. Next, I need to Compare next adjacent element, that is 78 and 80. The 78 is greater than 80? No. Again, no swap. The 67, 78, 80, 55, 13, 85. Next, I need to compare 80 and 55. 80 is greater than 55? Yes. We need to swap. The list is 67, 67, 78, 80, 55. The list is 67, 78, 55, 80, 13 and 25. Next, I need to swap next adjacent element, that is 80 and 30. 80 is greater than 13? Yes. We need to swap. The 67, 67, 78, 55, 13. We need to swap 80 and 13. 13, 80, then 85. Next, I need to compare next adjacent 80 and 85. 80 is greater than 85? No. No need to swap. Next, move on to this is the end of the pass 1. The largest number is 85 is in its correct position. The current list is 65, 78, 55, 13, 80 and 85. This is the pass 1. Next, we are going to perform pass 2. The compare 67 and 78. 67 is greater than 78? No. No need to swap. The list is 67, 78, 55, 13, 80 and 85. Next, I need to compare next value. 78 and 55. 78 is greater than 55? Yes. I need to swap. 67, 55, 78, 13, 80, 85. Next, I need to compare next adjacent elements. That is 78 and 13. 78 is greater than 13? Yes. I need to swap. 67, 55, 13, 78, 80, 85. Next, I need to compare 78 and 80. 78 is greater than 80? No. No need to swap. Then I need to move on to the next element. 80 is 80 and 85. Compare 80 and 85. 80 is greater than 85? No. The end of the list is 67, 55, 13, 78, 80, 85. This is the end of the past 2. The current list is 67, 55, 13, 78, 80, 85. Next, I need to do pass 2. Pass 3. This is the pass 2, right? This is the pass 3. So, I need to compare first two adjacent value. 67 is greater than 55? Yes, I need to swap. 55 is 55, 67, 13, 78, 80, then 85. Next, I need to swap next two elements. 67 is greater than 30? Yes, I need to swap. 55, 13, 67, 78, 80, 85. Next, I need to compare next two adjacent elements. That is 67 and 78. That is 67 and 68. 67 is greater than 78? No. So, no need to swap. Next, move on to the next element. 78 is greater than 80? No. No need to swap. 80 is greater than 85? No need to swap. The final list will be, the final pass 3 list should be 55, 13, 67, 78, 80, 85. This is the current list of the end of pass 3. Next we move on to the pass 4. Compare 55 and 13. First compare first two elements 55 and 13. 55 is greater than 30. 55 is greater than 13. Yes, we need to swap 13, 55, 67, 17, 78, 80, 85. 85. We need to compare. Next, 55 is greater than 67. Next two element. 55 is greater than 67. No. No need to swap. Next, 67 is greater than 78. No. No need to swap. Next two elements. 78 is greater than 80. No need to swap. 80 is greater than 85. No. This is the end of the current pass 4 list. Next, move on to the pass 5. First, we need to swap 13 and 55. 35 is greater than 55? No. So the list will be 30, 55, 65, 67, 78, 80, 85. This is the current list. No swaps were made. End of pass 5. No swaps were made, indicating that the list is sorted in ascending order. The final sorted will be 13, 55, 67, 78, 80, and 85. This is the final sorted list. Next, we are taking another example. Example 2. That is 90, 90, 25, 96, and 56, 65, then 78. First, we need to start pass 1. Compare first two adjacent elements 90 and 25. 90 is greater than 25. Yes, we need to swap 25, 90, 96, 56, 65, 78. Next, I need to swap next two elements, two adjacent elements, that is 90 and 96. I need to swap 90 and 96. 90 is greater than 96? No. No need to swap. Next, no need to swap. The remaining list is 90, 96, and 56, and 65, 78. Next, I compare next two adjacent list. That is 96 and 56. 96 greater than 56? Yes, I need to swap. That is 25, 90, 56, next I need to swap next two elements 96 and 65. 96 greater than 65? Yes, we need to swap. That is 50, 25, 90, and 56, 56, then 65, then 96, then 78. Then I need to swap next two elements, that is 96 and 78. The 96 is greater than 78? Yes, we need to swap it. The 25, 90, 56, 65, 78, 96. This is the current list. Current list of end of pass 1. The largest number is 96. Is in its correct position. The correct list will be 25, 90, 56, 65, 78 and 96. Then we move on to the pass 2. The pass 2. First we need to compare 25 and 90. 25 is greater than 90? No. No need to swap. The the list should be 25, 90, 56, 65 and 78 and 96. Then on to the next two elements. We compare next two elements, that is 90 and 56. 90 is greater than 56. Yes, we need to swap. Yes, we need to swap. 25, 56, 90, 65 and 78 and 96. Next, we need to swap next two other elements. That is 90 and 65. 90 is greater than 65. Yes, we need to swap it. 25, 56, 65 and 90, 78, 96. Next, we need to compare next two elements. That is 90 and 72. 90 is greater than 72. Yes, we need to swap it. The list should be 90, 25, 56, 65 and 78, then 90, then 96. Next, we need to compare next two elements. That is 90 and 96. 90 is greater than 96? No. The list should be 90, 50. The current list should be 25, 56, 65 and 78, 90 and 96. This is the end of past 2. The current list should be 25, 56, 65, 78 and 90, 96. When move on to the past 3. Past 3. Past 3, we need to compare first two elements. 25 is greater than 56? No. Because no need to swap. The element should be 25, 56. The elements of 25, 56, 65 and 78, 90 and 96. Then we need to compare next two elements 56 and 65. 56 greater than 65? No. No need to swap. The elements are 25. The current elements are 50, 25, 56, 65 and 78, 90 and 96. Then move on to the next two elements. That is 65 and 78. 65 is greater than 78? No. No need to swap. The elements are 25, 56, 65, then 78, 90 and 96. We need to on to the next we compare 90 and 96. 90 is greater than 96? No. 78 is greater than 78 it is greater than 90? No. 90 is greater than 96? No. The end of pass will be no swaps were made, indicating that the list is sorted in ascending order. The final sorted list will be 25, 56, 65, 25, 25, 56, 65, 78, 90 and 96. This is the final sorted list. The bubble sort algorithm has successfully sorted the list from smallest to largest. The final sorted order is 25, 56, 65, 78, 90, 90, 96. This is all about the bubble sort. If you like this video, please don't forget to subscribe, like and share and comment in this video.